Dear friends, this talk is on a subject which is of immense importance in the current times, and this is on Green ICU and what really Green ICU means and how this approach can be adopted in day-to-day critical care practice. Let us start with a case. A 60-year-old lady with diabetes and hypertension is admitted in the ICU with septic shock. She is intubated, mechanically ventilated, with associated humidification, piped oxygen delivery, and air. Multiple intravenous infusions, nasogastric feeding, as well as continuous renal replacement therapy are being administered for her prevailing condition. The heating, ventilation, and air conditioning system of the ICU, that is the HVAC, which is most commonly referred to as, is on. Similarly, the lighting and the machines are on. And there is a large bin which is placed beside the patient at the bedside for segregation of the waste. Now the question arises, what are the environmental concerns during management of this patient in the ICU? The patient, the lady with septic shock. And if we carefully look into the equipments being used, the surroundings in which she is placed and in which she is positioned, and if we want to analyze them, we will find that everything in this clinical scenario has a carbon, ecological, and waste footprint. A carbon, ecological, and waste footprint, I repeat. Now, although we are familiar with all of these terms, but sometimes confusion prevails as what is actually meant by carbon footprint, how different it is from the ecological footprint or waste footprint, and how do they affect changes that are harmful to the environment, and what can we do to reduce the impact of such change. Now, to understand that, we have to know the simple definition of carbon footprint. That carbon footprint is nothing but an indicator that represents the amount of greenhouse gases. So these greenhouse gases are the ones which are present in the atmosphere and which can trap heat from the sun. And these greenhouse gases are responsible for temperature, the climate change, melting of glaciers, biodiversity change, and all the different epiphenomena that are linked with the climate change. So these greenhouse gases, the amount of the carbon footprint represents the amount of greenhouse gases, and these are expressed as carbon dioxide equivalent, because carbon dioxide is considered as the key greenhouse gas, although there are other gases along with, like the methane, the nitrous oxide, and the fluorocarbons, all of which have immense potential to trap heat and thereby produce changes in the climate. So all these gases which are directly or indirectly emitted as a result of a specific activity within the ICU constitutes a carbon footprint. So the focus is, as I told, is usually on carbon dioxide, although there are other gases that contribute to this greenhouse effect, like the methane and the nitrous oxide. And to know that how we can calculate the contribution of each gas, there is a parameter which is called the global warming potential. And that parameter compares the heating power of a certain mass of this greenhouse gas, which is being investigated for, with the heating power of the same amount of carbon dioxide, so that the effect of these different gases can be calculated with the same unit of measurement. And this unit of measurement is called the carbon dioxide equivalent, or CO2 equivalent, expressed as CO2 small e. So having understood carbon footprint, we look into the different gases and their potential for global warming potential of these gases. Then we see that if carbon dioxide is 1, then for methane it is 28, for nitrous oxide it is nearly 10 times the methane, that is 265. And for the fluorocarbons, it is much higher, to the tune of 11,000 to 23, 24,000. So all of these are potential harmful agents for the environment. If you look to the literature, in a study in a patients of septic shock, McGain in 2018 calculated the average daily greenhouse emissions in the ICUs, and he found that the daily greenhouse gas emissions were 1678 kg of carbon dioxide equivalent and 88 kg of carbon dioxide equivalent in the ICUs in US and Australia respectively. So anyway, that was an isolated study, but it compared two places where the ICU practice was very, very intense, and all the equipments which can generate such greenhouse effects were used in abundance. But if we look into the figures, we find that this variation must be gradually becoming more and more as more and more equipments and gadgets become added to the ICUs, and there is more chance of carbon dioxide production or carbon dioxide equivalent generation because of the greenhouse gases. Another estimate of carbon footprint in a US hospital showed 138 kg of carbon dioxide equivalent per bed per day for ICU patients, and that was in 2022 study. And this corresponds to an emission of car driven 500 to 1,000 kilometers per patient per day. So it clearly shows the magnitude of the problem, the amount of gases that are escaping as a result of specific activities in the ICUs, and nothing is lost. Energy is always there. So all of this is continued to have an impact on the environment. So if you see that NHS England estimated that the pharmaceuticals and medical devices represented around 20% and 10% of the total carbon footprint of their healthcare system. So a good amount of this healthcare system can be controlled if we know the means of achieving those objectives on controlling their uninterrupted emission. Next question is then, what is ecological footprint and how do we calculate it? From carbon footprint, we move on to ecological footprint. We also label it as resource footprint. So it is a measure that indicates how much resources from the environment are required to support a specific way of life. That is, how much of the resources is being extracted from the environment for use in the ICUs, and whether there is any chance that this amount of resources can be reduced or can be used in some form so that their harmful effect on environment is reduced. In simple words, it indicates the amount of pressure that we as humans exert on our natural resources available to them in our surroundings in order to run the ICUs. So ecological footprint calculation is again based upon a complex formula, sum of TI by YW into EQFI, where this TI is the annual amount of tons of each product that is consumed in the nation. So it is difficult to calculate individually on the basis of ICUs, but once we know the gross data, then probably it is possible to derive it out from them, because it is the summation which speaks about the total footprint calculation. But it is easily understandable that we use a lot of resources in the ICU. For example, if we are using papers, we have to fell trees. So likewise, if you are using other forms of consumables, they are being also derived from some kind of natural resources and those are being replenished at a much lower rate in which they are being used. So it is important to understand that the ICU generates around 7.1 kg of solid waste and 138 kg of carbon dioxide equivalent per bed per day. This is also a finding in a 2021 study. And this most emissions originate from purchase of consumable goods, building energy consumption, purchase of capital equipments, and food services. So if we now look into the waste footprint, the third kind of footprint that is relevant to the ICU, then and try to figure out how to calculate it. So waste footprint is the amount of waste produced by sourcing ingredients and materials, manufacturing and processing and transportation. And a lot of studies have tried to measure the amount of waste that is generated by different areas of the hospital, and mostly these amount to the infectious waste, pathological waste, the sharps, needles, the chemical waste, the pharmaceutical waste, the general waste, etc. And it is good to have the recyclables included so that the effect of using recyclables on reducing this waste as a burden or reducing waste footprint can be calculated by subtracting those recyclables. Now, a few studies like the Corbin study in 2022 have calculated waste generation of 4.9 kgs per patient per day after using recyclables. If in contrast to Furukawa study of 2016, where the data is almost as high as 13.7 kgs per patient per day. So there is a lot of variation in the data, but definitely once the recyclables are included, then there can be a tendency towards a reduction of the waste footprint, if not the actual waste. So what is a green ICU? To most of us, green ICU is a concept which cannot be seen. True, green ICU is not something which has to be painted green from outside, or the walls have to be painted in shades which resemble environment or a nature friendly, but it is something, an initiative, a multidisciplinary initiative which aims to develop evidence-based guidance for reducing environmental footprint of the critical care practice. Now, clinicians can lower ICU's environmental burden through awareness of these carbon hotspots which exist in the ICU and integrate carbon reduction in decision-making and in activities in clinical practice while continuing to provide the high quality of care in the ICUs. One has to remember that not all actions and processes that generate the carbon footprint, which is worrisome, which is harmful, and all those activities which use resource use, which causes plastic waste, not all of them are essential for patient care. So the plastic use can be reduced. The single-use consumables can be reduced. The life cycle assessment of the devices should be done to ensure that those which are at the end of the life cycle, which consume a lot of energy, are weeded out and they're replaced and in a phased manner to avoid any generation of such wastes. So what are the steps towards green ICU? That there are at least 4 areas we have to consider. One is the area of consumption, waste, toxins, and personal footprint of the staff. Always we need to consider that in ICU, less can be more. And to contemplate this less can be more principle in practice, we have to understand that certain actions should be forcefully controlled if they are felt are of limited interest or of no interest to the patients. Avoid, reduce, reuse, and recycle program. So in clinical parlance, we refer to as 3 R's: reduce, reuse, and recycle. But In actual practice, it is called avoid, reduce, reuse, and recycle program, in which certain consumables that are responsible for increasing the waste footprint or the ecological footprint can be avoided. Certain substances which are necessary, like for instance, power is necessary to run the machines, the ventilators, etc. But how to reduce the consumption of energy is a concern. Reuse certain, for example, a lot of times there are plastic disposables in the form of plastic bottles, the blood sets, the syringes that are thrown, they cannot not reused. But we have to find means how reuse of items can be practiced. And of course, recycle program should be needed. Daily rounds are very important because we have to consider the ethics and futility. The patient requires admission in the ICU, the patient should be admitted. If the patient doesn't require the further stay in the ICU, the patient can be shifted probably. That way, we can minimize the occupancy of the ICU and also save on the fronts of environment. Life cycle assessments periodically should be done of all the processes and the systems that are incorporated in the ICUs, with the stress on reduction of energy, and definitely setting up of the green teams who can monitor the effect of the activities in the ICU on the environment and suggest steps which can reduce the carbon footprint or the resource footprint and the waste footprint on the ICUs, and application of these principles throughout the ICU, throughout the year, in a way that a sustainability is maintained. So the other important thing that we missed is we didn't discuss earlier was the toxins. So we'll know that a lot of times toxins are products. The products which are used in the ICUs generate a lot of toxins, and these toxins are also hazardous for the environment. And we should have means and ways to control those toxins or to shift to such methods where generation of such toxins can be avoided. For example, the simple mercury sphygmomanometer, the thermometers and the sphygmomanometers of mercury. And this is a toxin because it is a neurotoxin. It can be replaced with digital and dot matrix or the anaeroid ones. The brominated flame retardants, which are generated from the electronic equipments, can have neurobehavioral toxicities. They can cause thyroid hormone disruption and should be replaced with the suitable non-halogenated retardants. Cadmium, which comes from the patient's bedding, biohazard bags, etc., can have excess water or thinning solution used and can produce some kind of occupational injury and should be replaced by microfiber mops and clothes for cleaning. Similarly, glutaraldehyde, which comes from the general disinfectants and stimulants, is a respiratory and skin irritant and should be replaced with orthocaldehyde, hydrogen peroxide in clothes cleaning technologies. And the same is true for latex, PVC, lead, which should be substituted by suitably with other devices. So all of these toxins which are generated that can be harmful to the individual and the environment can be stopped if it is ensured at an early stage that they are replaced even before the use. So if we have to reduce the footprints of the ICU on the environment, we have to take care of the consumption. Consumption improves energy reduction, energy efficiencies, as well as responsible purchasing of such materials or such gadgets and devices where this energy conservation is maximum. In terms of toxins, as I told you, for the leaching and the looking at the equipments, so that the generation of toxins can be avoided totally, and definitely if cannot be avoided totally, should be at least prevented to the maximum possible extent. The staffing, we know that the personal footprints, the travel and the feeding and the food habits of the staff, as also those who are part and parcel of the ICU, can also affect the environment. So simple measures like if someone is taking a printout, using both sides of the paper can reduce. It's a simple thing, a simple suggestion, simple act but even that is very useful. If the staff is bringing the food for his tiffin, that it is in such should not be diverted from using polythene bags, etc., so that that cannot leave a ICU footprint. For the wastes, it is good to recycle, reduce, and reuse them wherever possible and whenever possible. And if at least some part of these four, consumption, toxins, staff, and waste, can be streamlined, a lot of footprints of the ICUs in terms of carbon, resource, waste, and toxin can actually come down to a significant level. So what common measures can be useful that can be undertaken that are useful for all the ICUs, be they small or large, in a city or in a town, etc., for reducing the carbon emission? So first is that we have to choose Energy Star compliant electric equipment, as we do as much for our home. The same thing should be done for the ICUs, particularly with regard to the patient bedside monitors, televisions, refrigerators, computers, etc., so that the energy efficiency improves and carbon footprint is reduced. Set computers to standby mode, and this computers means essentially the computers which are attached to the monitors when not in use, because simply switching to screensaver mode does not reduce energy consumption and may even increase it with heavy graphics processing. So we have to put into standby mode. Use timers and power bars for equipments that use a standby function to reduce their consumption to zero in quiet periods where we don't need them. And we use sensors to control lighting in areas of intermittent traffic and variable daylight, rather than putting on the lights all the time across day and night. We can use temperature control that is flexible in both timing and isolating geographical areas where the requisite cooling may not be required, or at times where the the temperature range can be changed in certain areas of the ICUs, and not necessarily that the same temperature has been maintained in all the spots. So these are the common measures which can be adopted and practiced in all ICUs. So if we try to analyze even more discreetly, we will have to see that we have to avoid or prevent unnecessary resource use, optimize supply with demand, avoid inappropriate admissions and readmissions, avoid low value care, always use care bundles aimed at preventing complications. This is necessary to prevent unnecessary resource use, or which comes under the heading of avoid. To optimize the patient length of stay, so we have to consider what we use should not repeat blood tests if not needed. We should avoid changing lines and syringes unnecessarily, minimize drug wastage, because whatever we wasted, we are actually throwing it to the environment, optimizing the supply stocking to reduce waste, and bear below the elbows without routine gloves. So these are some of the ways which we can reduce the use of resources. Consider those reduction if interventions are needed, and ask ourselves, will this test change my management? The third is the reuse, where we can reuse the personal protective equipment, blood pressure cuffs, pulse oximeters, the laryngoscopes, linen, procedure packs, etc. But we have to note that some single-use items could be reused for the same patient throughout their hospital journey. And it is not that we are using it for other patient, but we are using in the same patient that can be sincerely tried and used. Fourth is the recycle, that put the recycling and waste in the right place, educate everyone about the benefits, and there the clinicians should try to maximize the recycling. And disposal, avoid if possible the use of waste, sharps, and infectious waste, and the waste bins correctly, etc. So less CO2 emissions from recycled plastics than plastics. So if we use those plastics rather than using new plastics, probably even if there is some amount of CO2 emission, but that CO2 emission is much lesser in comparison to newer plastic. So Patient-centered intensive care should be patient-centered to meet the health needs, the ICU needs, but they should also be realistic, responsible, affordable, and sustainable without impacting the planetary health. To do good to a patient, we should not do harm to the millions and crores of population in our planet. Now, all such actions that we undertake to practice the protect the environment for sustainable environment, reduce the carbon resource and the waste footprints in the ICU should be analyzed. They can be analyzed and they should be analyzed through medical care, where energy expenditure, energy use, and type of the care, etc., should be audited. Life cycle analysis or cradle to grave analysis of the environmental impact of natural resource extraction, manufacturing, packaging, transport, use, reuse, recycling, disposal of product or process waste, etc. should be done. Material flow analysis, because that can quantify the material and waste flows entering and exiting the system. The system means ICU here in a given space, like that a patient admitted in an ICU on a particular time of the day, etc. The carbon footprint, which represents the total volume of the greenhouse gases, and also identifying the impact of the way we dispose our waste. We means we as healthcare professionals and not the patients alone. Therefore, to summarize, we have to understand that climate change and environmental stewardship are promoting change in our societies in all parts of the globe. And even beginning early in students, right from their middle school, they are being educated or taught about the climate change, about environmental protection, and etc., environmental stewardship. Now, intensive care units use large amounts of energy, pharmaceuticals, and single-use consumables, and all of this we know can have a potentially harmful impact on the environment. So the environment sustainability in a critical care setup should be viewed via this framework which we have discussed: avoid, reduce, reuse, recycle, and to which I can also add two more, the words rethink and research. So let us be part of the solution and not part of the problem. And in order to be so, we have to continue painstakingly our efforts as intensivists, combined with newer methods or newer engineering skills, better waste management tools, and procurement services. All of this is necessary to save our planet, prevent climate change, and at the same time possible to deliver the best possible care in the critical care unit. Thank you very much.